T-minus 10, 9, 8, 7, 6, 5, 4. Main engine start. 2, 1, 0. And liftoff of the Delta II rocket with Phoenix, a distant science outpost seeking clues of the evolution at the polar region of Mars.
On August 4th, 2007, NASA shot a robot into the sky. The purpose of this robot was to assess the possibility of microbial life on Mars and to analyze the history of water on Mars. The name of this robot? Phoenix. Phoenix was a part of the Mars Scout program, an initiative to send several low-cost robotic missions to investigate the history of life and water on Mars. This information is important because it helps us understand the history of climate change on Mars, which might be able to help us understand climate change on our own planet. It also allows us to assess the habitability of Mars for colonization. This mission was led by the Lunar and Planetary Laboratory at the University of Arizona, under the guidance of NASA JPL. It was the first mission in NASA history to be led by a public university instead of being run by the United States government. This mission was the 6th successful landing on Mars and the first successful landing in the polar region of Mars. The University of Arizona enlisted the help of Lockheed Martin to develop the lander that carried their scientific payload to Mars. Lockheed Martin has been the biggest purveyor of aerospace, defense, and space utilities since 1928. They have a track record for reliably delivering scientifically and technologically sophisticated projects, so they were the logical choice to deliver the Phoenix mission. The purpose of this mission was to conduct a focused geological survey of ice soil to determine the habitability of Mars for future human expeditions. Ice soil is literally soil that contains frozen water. Initially, the plan was for it to last 90 Martian sols, or around 92 Earth days, to analyze various ground samples using a method called wet chemical analysis. Wet chemical analysis is a form of analytical chemistry that uses flame tests and colorimetry to determine the chemical composition of the soil. It also employed an atomic force microscope and a gamma-ray spectrometer to find the concentration of hydrogen in the soil. Phoenix found the soil to contain elements such as magnesium, sodium, potassium, and chlorine. This combination of minerals causes the surface to be very alkaline. It also found that the soil contained 0.6% perchlorate salt, which makes the soil highly toxic. Perchlorate salt is what's used to make chlorine gas. The other components that make up the ground on Mars are water, silica, and iron-3 oxide, commonly known as rust. The final piece of instrumentation featured on the Phoenix lander was a Canadian-made LiDAR system, made to monitor the atmosphere during the mission. This is particularly notable because the Phoenix Surface Stereo Imager managed to capture it in action. The bright spots featured in these images are points where the laser encounters ice crystals in the Mars sky. This acts as further proof that Mars has water. The scientists on the project were hoping that the craft would last until the Martian winter, so it could observe the polar ice form on the Martian surface. But it could not handle the harsh dust storms and increasingly dark and cold environment. Sadly, the craft only lasted 157 Martian sols out of its predicted 90. The craft was barely hanging on, but still relaying messages, eking out an existence on the surface of Mars, trying to survive the long, dark, cold days, but for some reason seemingly unable to get a complete charge. Last contact was on November 2nd, 2008. In total, the mission lasted 1 year, 2 months, and 29 days, from launch to final contact. The folks at NASA and the University of Arizona were unsure why it quit. It was cold and dark, experiencing minimal daylight to power the solar panels, but it should have been enough to continue operations through Mars winter. It wasn't until 2010 that NASA's Mars Odyssey orbiter captured a picture that revealed its fate. One of the solar panels had disappeared, presumably from the very frequent, very harsh dust storms on Mars. Though the mission had finished years prior, it wasn't declared over until May 24, 2010, just days after they received the final orbital photos of Phoenix. The mission is considered a success because it was able to produce all the data needed and more, but it still didn't accomplish all that was hoped for. The Mars Scout program opened the door for the modern desire to become a multi-planet species. Once it became public knowledge that there were large quantities of ice in and on Mars, there was no going back. Subsequent programs like Opportunity, Curiosity, and Insight may have not come to fruition if Phoenix had not established the possibility of a future for humans on Mars. The SpaceX plan to colonize Mars would never work without the discoveries of Phoenix and Maven, and humans may never have had a chance to expand beyond our planet.
The fact is, Mars needs moms.